We go back to considering the unit circle, the circle with radius 1, and we've seen how we can associate each point on the circumference of the circle with an angle, a directed angle, that from here is 0 degrees, to here becomes 90, 180, 270, 360. And if we count in the opposite direction, the angle can get negative. We've also learned how to associate this angle with a sine and a cosine. The sine is the projection on the y-axis, and the cosine is the projection on the x-axis, where if the projection is on this side or on this side, it is positive, and if the projection is on this side or on this side, we define it to be negative. Today, we're going to get familiar with two more terms, the tangent and the cotangent of the angle here. For this, we're going to introduce two more axes. This axis, which I'm defining as tangent to this circle at this point, at the point of the 0 degrees angle, this is called the tangent axis. And the tangent axis also has a positive direction, which is this direction, and a negative direction, which is this direction. And so if I measure lengths on this axis, the lengths on this side would be positive, and the lengths of this side would be negative. The symbol I'm going to use for tangent would be tan. And now I'm going to introduce the cotangent axis. This here is the cotangent axis. It is tangent to the circle at this point, which is the point corresponding to 90 degrees angle. And it also has a positive side and a negative side. The positive side of the cotangent axis is this side, and the negative side is this side. So if we measure distances, all distances on this side would be positive, and on this side would be negative. Of course, when we measure distances, I mean distances to this point here. About this axis, when I said we measure distances, I again meant distances from this point to any other point. So if the second point is here, it would be positive. If the second point is here, it would be negative. The first point is always here. And similarly with this axis, if the second point is here, it will be positive. If the second point is here, the distance would be negative. But the first point is always here. The symbol I'm going to use for cotangent is this one. And now the question is, how do we define the tangent of this angle here? And how do we define its cotangent? Well, suppose this angle is alpha, and it corresponds to this point on the circle. So I'm going to take this line and I'm going to continue it until it intersects the tangent axis at this point and the cotangent axis at this point. Now this point on the tangent axis defines a distance from this point to this point. In this case, the distance is positive because the second point is on this side of the axis, and the magnitude of the distance is just the length of this segment here. This length we call the tangent of the angle alpha. Similarly, this point lies on the cotangent axis, and it defines a distance, the distance between this point and this point. In this case, the second point is again on the positive side of the cotangent axis, and therefore this distance here would be positive, and it would correspond to the cotangent of the angle alpha. And this is it. For any angle alpha, we take the line that corresponds to the angle, we intersect it with the axis, the tangent axis, and then we take this distance and we call it the tangent of alpha. We also intersect it with this axis, the cotangent axis, and then we take this distance and we call it the cotangent of alpha. Now let's try to analyze how the tangent and the cotangent will behave for different values of alpha. And in the meantime, we're going to fill in these two tables. Well, first of all, let's look at the 0 degree angle. This line, which corresponds to the 0 degree angle, intersects the tangent axis at this point, which corresponds to 0 distance. The distance between this point and itself is 0. And this line doesn't intersect the cotangent line at all. So the cotangent of 0 degrees is not defined. Next, what happens when we increase the angle a little bit? What happens for angles between 0 degrees and 90 degrees? Well, the tangent starts becoming positive because then this line would intersect the tangent axis on the positive side, and it's going to increase and increase and increase and increase when the angle increases, and when the angle approaches 90 degrees, the tangent will become really, really large, and at the 90 degrees, this line wouldn't even intersect the tangent axis. Therefore, the tangent of any angle between 0 and 90 degrees is positive, and tangent of 90 degrees is not defined. What about the cotangent? For small angles, for example, for 1 degree angle, the cotangent would be really, really large because the line would intersect the cotangent axis somewhere far. As the angle increases, the cotangent decreases, but it always stays positive until we reach the 90 degrees angle when this line intersects the cotangent axis at 0. And so cotangent of 90 is 0, and cotangent of any angle between 0 and 90 would be positive. But what about angles between 90 and 180? Well, this line would intersect the tangent axis on the negative side, and so the tangent of an angle between 90 and 180 would be negative, and the cotangent axis again at the negative side. So the cotangent of an angle between 90 and 180 will again be negative. At the 180 degrees, the line wouldn't even intersect the cotangent axis, and so the cotangent of 180 degrees is not defined. And it would intersect the tangent axis at the point 0, and so tangent of 180 degrees is 0. For angles between 180 and 270, this line would intersect the tangent and the cotangent axes at positive points, at this side of the axis and this side of the axis. And therefore, tangent and cotangent of angles between 180 and 270 will be positive. At the 270 angle, we would have this line. It doesn't intersect the tangent line, and it intersects the cotangent line at the point 0. And finally, for angles between 370 and 360 degrees, this line will have this line, which would intersect the tangent axis on the negative side and the cotangent axis again on the negative side. Therefore, tangent and cotangent of an angle between 270 and 360 degrees would be negative. The optional problem would be to find these quantities, and here's the solution. So here I've drawn the unit circle, the x-axis, the y-axis, the tangent axis, and the cotangent axis. And suppose this is the angle alpha here, so it makes this line, which intersects the tangent axis here and the cotangent axis here. Therefore, this distance here would be tangent of alpha, and this distance here would be cotangent of alpha. Now let's see what happens when we take 180 minus alpha. What happens with the tangent and the cotangent? Well, if I take an angle alpha here, then this point would correspond to a directed angle of 180 minus alpha, because this whole part is 180 degrees, and then we subtract alpha from it. And therefore, this point and this point are symmetric with respect to the y-axis. And therefore, when I construct this line, it would be symmetric to this line with respect to the y-axis. Now that I take this symmetric line and intersect it with the tangent axis and the cotangent axis at this point and this point, then I can see that this length is the tangent of 180 minus alpha, with a negative sign because it's on the negative side of the tangent axis. And when I intersect it here with the cotangent axis, I can see that the cotangent of 180 minus alpha is this distance with a negative sign because this point is on the negative side of the cotangent axis. Notice that we also have that this line is symmetric to this line with respect to the x-axis as well, not just with respect to the y-axis. And now we can see two isosceles triangles in the picture. This triangle and this triangle. They are isosceles because of the symmetry, and therefore cotangent alpha equals cotangent of 180 minus alpha, but with the negative sign, because this one is on the positive side of the axis and this one is on the negative side of the axis. And when we look at this triangle, we see that tangent alpha equals tangent of 180 minus alpha, but don't forget to put the negative sign, because this is on the negative side of the axis and this is on the positive side of the axis. Now let's look at tangent of minus alpha and cotangent of minus alpha. Well, let's take the angle minus alpha. So we start here and we count alpha degrees in the opposite direction. And this is this point. And so the line that we need to intersect with the tangent and cotangent axis is exactly the same as the one that we used when we had this point, 180 minus alpha. And so the tangent and cotangent of minus alpha would be equal to the tangent and cotangent of 180 minus alpha. And so tangent of minus alpha equals tangent of 180 minus alpha, which is negative tangent of alpha. So we put negative tangent of alpha here. And same thing, cotangent of minus alpha equals cotangent of 180 minus alpha, which is negative cotangent of alpha.